And let us please welcome to the stage our next company, Harmony Aeronautics, out of College Station, Texas.
Good morning, everyone. My name is Fareed Saimi. I am an aerospace engineering PhD student at Texas A&M University and a co-founder of Harmony Aeronautics. I've got some cool stuff to show y'all, so let's get started. All right. So it seems like everybody and their mom is tripping over themselves today to design some sort of new electric air taxi or electric air scooter. And it's all very exciting. McKinsey estimates this market to be worth about $20 billion by 2030. However, NASA has identified noise to be a problem with electric aviation. And I'll show you why. I'm going to play a video clip from about 2 or 3 years ago. It's a 60 Minutes news segment. Pay attention, the guy running away on the left is not the reporter. It's actually the company CEO. He didn't realize just how loud his own product was going to be.
His breakthrough invention,
what we're going to do is we're just going to run
is a small but extremely powerful electric motor.
This can produce 130.
It's pretty loud, pretty embarrassing. And what's crazy is that was just one propeller. Imagine 4 of these on a delivery drone, 6 of these on an air taxi, or 18 of these on an air taxi, or 2 massive sets on a hybrid regional jet. Okay? Excuse the pun, but this is not going to fly. People are not going to want these things buzzing over their neighborhoods. The military is not going to want to use them because the enemy will know you're coming from more than a mile away. And this may turn out to be a dud like the Concorde back in the 70s. And you know, noise isn't the only problem. A propeller's efficiency peaks at low RPMs. At high RPMs, you get that very loud and irritating noise. And that's because the human ear has evolved to be very sensitive to high-frequency sounds like a baby crying or an animal screeching to come get you. And unfortunately, that is where electric motors, are most efficient. So the peak efficiencies do not line up. And there's a second kind of double punch. Electric motors are most power dense. They put out the most power per unit weight at high RPMs. So even if you decided to take the efficiency hit and spin everything slowly to be quiet, you would have to massively oversize your motor to get the same amount of power. So it's a double whammy here. So if we're looking at quietness on one axis and compactness and efficiency on the other, if you want it to be really quiet, you're going to have to suffer massive motors, and your plane may not even get off the ground. If you want to be compact and efficient, at least on the electric side, you're going to have to suffer high-speed propellers, like we just heard. If you throw in mechanical gears, you can be somewhere in the middle, but then you have an entirely new set of problems in terms of vibration and maintenance. So what are you going to do? You're going to buy Harmony's silent drive propellers, that's what, okay? The silent drive is an integrated propulsor that contains a quiet propeller, an innovative magnetic gear system, an electric motor, a motor controller, and a thermal management system to keep it all cool. All right. What does it do? It aligns those efficiency curves that I talked about at the peak operating point, all while avoiding that loud flight regime that we heard. And we're maintaining the compactness of a high-speed system with the reliability of a direct drive system. And it's an all-in-one system. Oh, there we go. It's an all-in-one system that you can slap onto a drone, an air taxi, or an even larger hybrid regional jet. What does that mean for the end user, for the customer? Well, an air taxi equipped with this will not wake up the neighbors when you fly in. It won't wake up your kids. A military system equipped with this technology will not alert the enemy that you're coming. We're squeezing more power per unit weight, so that translates into longer range, a higher endurance. And we're minimizing your maintenance requirements, you're maximizing reliability, so that translates into lower operating costs and a cheaper ticket for the consumer. And what's great is that this is a scalable and certifiable solution for drones, air taxis, and even hybrid regional jets. How does some of this work? First off, we have the quiet propeller. We've patented a very unique design with some special sauce that I can't really talk about. But what I can do is demonstrate the quietness. So first I'm going to play a clip of just a standard quadcopter drone that you may buy at Best Buy. And then I'm going to play a clip of our system equipped on a similarly sized drone. Excuse me. Pretty irritating. It's a heck of a lot quieter. In fact, it's 1/8 as quiet as the quadcopter that we just heard. And this isn't just some tinker toy that works in the lab on Tuesdays when the stars align. We have flown this technology at a small scale, a 22-pound drone, as well as a large scale, a 550-pound eVTOL system. So I'll play you a clip now. If you didn't catch the blurb in that video, the full-scale system was 73 decibels at 50 feet. Google's Heaviside aircraft, which is similarly sized, put out more than 80 decibels at 150 feet. So we're not just quieter than the competition, we're quieter even when you measure our noise at a closer distance, which is pretty cool. Now let me talk a little bit about the magnetic gear and electrical innovations that we have. We at Harmony have partnered with a fellow A&M startup called Fluxworks, run by some very talented electrical engineers, and they've come up with some very efficient magnetic gear topologies. When I mean efficient, I really mean efficient. 99% efficiency at full load, all while creating zero backlash and no contact between the gears. It's all magnetic. So intuitively, that makes sense that you will have higher reliability and lower maintenance costs. And again, this isn't just some tinker toy that works in the lab. We've validated this at two vastly different scales. We have a 30 Newton meter benchtop setup, and you can see the high speed, low torque system on the left and the high torque, low speed system on the right, as well as a 3,000 Newton meter industrial setup. So again, experimental validation on vastly different scales. How do we want to turn this into a business? We would like to develop a product line of certifiable propulsors for first drones, then air taxis, and then hybrid jets. We think this is a good idea because we already have all the right stakeholders knocking at our door. Established companies like Boeing and Sikorsky are interested in our technology, as well as new eVTOL aerospace startups like Beta Technologies. And we have interest and development contracts from government stakeholders like NASA and the Air Force. And not to mention, there's a lot of spin-off potential for on-the-ground terrestrial applications like quiet fans, compact generators for consumer and industrial settings. We would like to take advantage of NASA's upcoming Susan program. It's a tech demonstration program that should start in 2022. That serves as a non-dilutive funding opportunity for us to develop and flight test a propulsor for large drones or maybe even small air taxis. The great thing about going to the drone market first is that it's unregulated, so we don't have to certify the propulsor. We can just go straight to market and start generating revenue by early 2024. After that, if we would like to certify a air taxi propulsor, we can take advantage of the Air Force's Agility Prime program. They've streamlined the certification process, and if we can leverage our interest with those big players like Boeing into a strategic certification partnership, then we can reach the eVTOL market and start generating revenue with reduced costs and reduced risk. Later on, we can come back to Susan and take advantage of another non-dilutive funding opportunity to develop a hybrid jet propulsor. That would be its own certification campaign, and also leverage revenue from spin-offs like sub-licensing to terrestrial applications. So not a pie-in-the-sky research project, quite literally. Who are our competitors? Some of you may have heard of Whisper Aeronautics. They're a similar company to us, trying to look at quiet propulsion for eVTOL. But as far as we know, they're just looking at the propeller, and they don't have anything flying yet, unlike us. Some of you may have heard of Hex Technologies. They're trying to develop a power-dense electric motor for aviation, but they're just looking at the motor side, and they're looking at 11 kilowatts per kilogram. We at Harmony and our partners at Fluxworks are looking at the entire picture, an integrated propulsor that can put out up to 13 kilowatts per kilogram. So we've got them beat. And we're very confident that we can beat the competition because we have great aerospace and electric talent under our umbrella. What we're offering is very compelling to airframe manufacturers. We're taking this very complex piece of equipment, the propulsion system, and letting the airframe manufacturer worry about designing the airframe, and just a plug-and-play propulsion solution exists for them. And we're flight-proven. What more can you ask for? Our leadership team at Harmony includes myself and our CEO, Dr. Mobile Benedict. He is a world-renowned rotorcraft expert. Our partners at Fluxworks include Brighton Proslika, who's with me in the audience today, as well as Dr. Hamid Toliat, a world expert in electric motors. And we're being advised by some very successful experts and mentors in the defense, tech, and venture capital world. So we're confident we can develop our startup into a proper business. Talking about the market again, like I mentioned, the first product we would like to develop is a propulsor for drones. Our target customer would be a UAV manufacturer for the Defense Department. Those guys have to buy American, build American. So that's a foot in the door for us. And with 2,000 units at a unit price of $20,000 per propulsor, we're looking at a market value of $40 million. After that, we would tackle the eVTOL or air taxi market, and our target customer there would be an air taxi manufacturer. With 1,000 units at $150,000 each, we're looking at a market value of $150 million. Finally, we would tackle the hybrid jet market. Our target customer there would be a regional airline. And with 100 units at $10 million each, we're looking at a market value of $1 billion. Not to mention, we have those spin-off opportunities, like I mentioned. So we can sub-license some of our innovations for flight control actuators, wind turbines, and other industrial machinery on the ground. Just to give you a quick summary of our company, we started back in 2018, and in the span of a year and a half and $300,000, we designed, built, and flight tested a TRL-6 prototype. So that was the aircraft, the full-scale aircraft that I showed you earlier. We just wrapped up phase 1 of an Air Force STTR, and our goal now is to further increase the TRL of our technology. So we're waiting to hear back on phase 2 of that Air Force contract. If the Air Force is watching, please let us know. We'd like to increase the TRL of that prototype up to TRL 9 in phase 2. And then after that, we'd very much like to develop this propulsor through the Susan program. And with that, I'll wrap it up and open it up to questions. Thank you for your time.